Now that we have explored the theory of clustering and specifically segmentation, let's look at a practical example of it. And for this, we're going to revisit the original data set before we scrubbed it. Now, we've been working along up till now with the insurance data set. And after the first module, we scrubbed that and we fixed the missing values when we converted the characters into numeric values using one-hot encoding. We're not going to do that right now. Let's just go back to the raw data because I want to do some exploring of segmentation. So let's look at that. Let's load that data in. And if we look at that, let's use the head command. You can see here that we have, this is all raw data. Let's expand this a little bit and try that again. Okay, so you can see here that we have whether or not they crashed their car, how much it costs, but we have some categorical data that we can use to segment. We can say, well, maybe we're going to segment our customers based upon whether or not they're single parents. Maybe we can segment them based upon the fact that they're married or single, or that they're females or males, or maybe their education, something like that. So let's start by, and again, recall that we did this in the lecture with animals. We said, was the animal big or small? Was the animal, did it eat meat or plants? Did the animal have fur or did it have scales on its skin? We're going to do the same thing with customers here, only we're going to look at different things that we can observe. Let's start off by looking at the sex of the customer. Now, when we look at this command right here, let's do this guy right here. This is going to tell us how many females and how many males we have in our customer base. Okay, so we have 5,500 females and 4,700 males. Let's call it, oh, I don't know, 55% and 45%, plus or minus. So we got more female customers than male customers. Okay, now let's first look at the probability of crashing our car. Now, the conventional wisdom in the insurance industry is that males tend to be more risky than females. Is that true? Well, whether or not we have our own data. Now, maybe that's true in general, but is it true for our customers? Maybe, because this is a data set from risky customers who have had, for some reason they want discount insurance. Maybe there's a difference here. So let's segment our customers and find out what we can, learn about this. So we're going to basically look at the probability of crashing your car, and we're going to break it down by sex, and we're going to look at the average here. And then we're going to shove the answer into AGG for aggregate. We can name this thing anything we want, but we're going to call it AGG. So let's put that in there. And let's type AGG and see what we get. So we see here that females have a 27% chance of crashing their car and males have a 25%. So there's a slight difference here, but wait, we've learned something new. The conventional wisdom is, in general, females tend to be safer drivers than males, but for this data set, for this insurance company, they've learned just the opposite. We've learned that females are slightly more risky, but is it statistically different? Who knows? But the point is, we at least now know that females are not safer than men. So what else could we learn? Well, we could say that a lot of times the conventional wisdom is it's not that men are more risky than women, it's single men, because young single males tend to be very risky because they drive, young teenagers, teenage boys tend to drive a lot crazier. So let's try to do that. Why don't we instead segment based upon your sex and your marital status? So let's do that. So now we're going to say the claimed flag, and let's say marital status and sex. So let's break that down and see maybe we can segment based upon your sex and your marital status. Will that tell us anything? Okay, so what do we have here? Single females, 35% chance. Single males, 31. So now I'm seeing that women in this data set tend to be riskier drivers than males. And if you are married, then it's about the same. So what I might do is I might say, well, I'm going to create 3 segments, married, and then single males and single females. Maybe I might do that. But I'm now learning something about this data set. So if I was an insurance carrier and I would say, well, my customer base, I find that single females, for whatever reason, tend to be slightly riskier than men, than everybody else. I might try to market only to married people to get less risk. I don't know. So this is teaching me something that I didn't know before. I could also look at other things. Okay, so I don't have to just look at the target. Maybe there's something else here. Maybe it's the MVR points. This is how many traffic tickets do you have. So what if we say, let's look at your sex and then look at how many traffic tickets you have. Maybe it's not the crashing of the car. Maybe it's just that our customer base has more traffic tickets. And when you like to speed, you tend to get into more crashes. So let's do this. So let's look at that. So we notice that the females have slightly more traffic tickets than do males. Again, is that significant? I don't know. We'd have to do an analysis to find out if it's statistically significant, but it's definitely directionally. The females in our data set seem to get slightly more traffic tickets and they get slightly more car accidents. So maybe we are marketing to a wrong crowd of people. Maybe we have to start marketing to, because if the conventional wisdom is that females tend to be safer, why are we getting the risky ones? Maybe we're underpricing risk. Who knows? We can also learn other things too. Let's do a table of our segment on sex and look at the jobs. Okay, so let's look at that. So this is sex based upon jobs. Let's do it the other way. I like it. I would prefer it to be in a column format. So let's put the job first. And then, whoops. And then let's put sex next. So that'll make it in a column format. Well, there we go. So missing right here, we don't know what your job is. A lot more men, we don't know what your job is. For some reason, now that's telling me something new, is for whatever reason, we've got a lot more females in our data set than men, but for whatever reason, we don't have the data. Maybe why don't we do that? This is telling me something. I'm learning something that I didn't know before. When we collect data, for some reason, for men, this is missing. Why is that? We would investigate that. Our database people would do that. What else do we know? Clerical, okay. About, it's again slightly more female than men, but we got slightly more females in our population. What about doctors? Slightly more females than men again. But look at this, homemakers. Lots of homemakers. Obviously, women tend to stay home more than men. So the fact that you are a homemaker, perhaps that is significant. Maybe we can do some analysis based upon your job. What about lawyers? Looks like we got more women than men, and this might actually be somewhat of a maybe is statistically significant. Maybe we got slightly more women than men. Managers, professionals, students. So it seems like there's, in general, the only difference between men and women in this data set is homemakers, which obviously women tend to stay home with kids more than men do, and the missing. That seems to be interesting as well. I might explore that. I've learned something new that I didn't know before. We're not collecting data. It wasn't what I went looking for, but I found that. What else could we look at? Maybe let's look at education. So let's do a quick analysis on that. So what if so it doesn't look like we're getting a lot of play here with male versus female. It doesn't look like there's a lot here. Let's segment based upon something else. What about education? Well, we have here PhDs, masters, bachelors, high school, and not graduating from high school yet. So that's our data set. Let's see if that's predictive of whether or not you crash your car. So let's see about that. So now you can see that your PhD is your safest driver. My master's degree is my next safest. My college degree is the next, and then high school and no high school, 34 and 32. It's a slight difference. It seems like your high school diploma people are slightly riskier. Is it statistically significant? Probably not. But the point is, we can see that there's a clear path here, is that the more education you have, the more safe you are. So I've now learned something. Now, what might that tell me is perhaps I could go to universities around the country, and as soon as a person gets their PhD, maybe I could get a list of PhD candidates and send them auto insurance marketing literature, something like that. We can get the safe drivers. So what else can we look at? Let's see about MVR points. How many traffic tickets do you have based upon your education? So again, it looks like it's slightly different. It goes slightly lower. The more education you have, the less traffic tickets you have. But it doesn't look like it's a big difference, 1.5 to 1.8. But there does appear to be a huge difference between driving risk. So maybe traffic tickets is not the key. What's different between one group and another? Maybe it's your travel time to work. So maybe if we look at that, because the more you're in the car, the more likely you are to crash it. So maybe PhDs don't drive as much. But if I look at this, again, it looks like the PhDs drive a little less than everybody else. 34 minutes in the car versus, maybe this is miles to work. Yeah. So, clearly the people who are more educated are closer. So maybe that's the fact. I'm still trying to explore. Nothing's jumping out at me. What about kids? Because when your kids drive your car, you're likely to, the kids are the ones crashing. Maybe the fact is that the PhD people have less kids driving. So maybe it's not the fact that I got a PhD. Maybe I just don't have the kids driving. So, whoops. So let's put that over here, see what we get. Aggregate. So now I can see that, interestingly enough, I've got the high school people have more kids driving than the PhD people. So that's an interesting thing, is I've got, the lower educated people have kids driving. So I don't know what that means. I'm just speculating off the top of my head. I might suggest that maybe the PhD people and the master's degree and the bachelor's, these guys have, maybe they're older and the kids have left. Because obviously, if you've got a PhD, you're probably older than the high school person. Maybe your kids are off at college. I don't know, because you can afford to send them to college because you got a PhD. I don't know, but I've got less, maybe that's it. Maybe I'm learning something new, is that the PhD people don't have kids driving their car, and you don't want a teenager driving your car. Well, maybe it's age. I don't know. Let's take a look at maybe it's the age of the person. So let's look at that. So when I do this, well, wait a minute, what's going on here? I've got a bunch of NAs here. That's because I've got a lot of missing values. And this R doesn't like this. When I run this command, because I've got missing values for bachelor's, high school, and no high school, I'm running into problems here. And I can't do it. So is there a fix? Well, here's the fix. If I put this command right here afterward, remove the missing values, then R will say, okay, if you got anything missing, I'm just going to ignore it. So this is a quick fix for missing values. So let's see what we get for this. And it looks like the PhD people are a lot older. So it also seems like maybe when you have a doctoral degree, obviously it takes more time to get this, so you're going to tend to be older. And if you notice, the average age seems to go down. So that's interesting. Maybe I don't have a lot of kids because I'm older and the kids have left home. I don't know. This is me just speculating. There's no right answer, but this is how you explore. You segment, and then you start doing some analysis. So you start learning new things, and you try to figure out what did you find out, and what can you do with this information. So this is segmentation, and you could do a lot with, there's lots of other variables, but the segmentation process with your customers tends to be a long process. You should explore all of the variables, see what it tells you, and then when you learn something, you have to follow up on it. Like, for example, when we found out that for some reason we didn't know why was there so many missing values for their job? That's something you have to follow up with and learn, because this is all valuable information. So anyway, this is segmentation using R. And let's now, in our next lecture, begin to look at clustering.